Fine. Good. Okay. The queue is a data structure. It is something like, first in, whichever the elements, assume this is my queue. And if I need to insert certain elements, say for example, 10, 10, 20, 30, and 40. And if I insert 10, it's come first serve. It's like any normal queue, right? So if I insert 10, it goes into the first, here. And then if I insert 20, it comes at this point in here. And again, if I insert 30, I'll insert at this. I mean, basically, I'm inserting at that one particular end. See, and then I'm keep appending it, right? 40, 50, and so on. So if I insert 10, if it goes at the bottom, not at the bottom, 10, and then 20, 30, 40, and so on. If I remove elements, I think there is a lot of disturbance. Okay, I'm muting. Just if you want to ask any question, please unmute yourself and then you can ask. So mine also, yeah. Fine. See, if I insert 10, right, it's 10 inserted at the very beginning. So if I remove the element, 10 has to come first. The order is something like first in, first out. Whichever the elements goes first into the queue, it should come out of the queue first. Here, I inserted 10 first. So if I remove, 10 will come first. And again, what are all the remaining elements in the queue? 20, 30, 40, 50. So again, if I insert another 60, it goes at this particular thing at the end of the queue. And if I remove any element, I need to remove 20. Basically, we do insertion from one end and then deletion from other end. Since this is I'm inserting 10, 20, right? This is the insertion point and this is the deletion point, because this came into the queue first, right? So it has to go out if I want to delete the items. See, what are the real-time applications of this particular queue, right? Even if you look at the scheduling, we're scheduling if the job priority is same for all the jobs, then it maintains the first in, first out order. That is one of the application. And also, if you look at any customer care services, right? If anybody, if we call up to any customer care, it's if only say for example only two attendees or only two people are managing all the calls. See, they pick the calls in the first come first serve order. So if I call up first, I'll get the turn first, or else whoever comes late, he gets his turn late. It's a basically first in, first out order. So what are all the operations we did here? If you look at it technically, see, I did one is the NQ. NQ means just I appended the elements, basically added the elements. And then what are all I can remove the elements, right? That is a DQ. And then probably we can check if the queue is empty or not. We can check whether the queue is empty or not. That is empty, we can put that. And then what else? Then if I want to get the front element, what is the item to be deleted? Basically, it's a front, right? These are all the possible operations we can do in the queue if it is a single queue. And also there is a various types of queue. It's just a queue, right? It's a single queue. Probably we can have a DQ also. DQ means it's a doubly ended queue. Here we did only insertion from one end and deletion from other end, right? The doubly ended queue means I can do insertion from this end and deletion from this end. Say let's call it a D1 and then I1. And also I can insertion from this end, I call it as I2, and then delete from this two. This is called D2. Positive, the thing is I can delete from both ends or I can insert from both ends. So even DQ also has its, we can using doubly ended queue, you can solve many, complex problems that we'll see a little bit later. So now these are all the possible operations: NQ, DQ, is empty, and front. Is it clear? If the theory is clear, we go ahead and implement the queue, and then after that we'll solve a couple of problems using queue. Hello. Any questions so far? Is it clear? Okay. Okay, just go ahead and implement the queue here. Yeah. See, let's call it as a queue. This is the queue, right? This is a queue class. See, what are the operations I need to make? First is, I'll call this is the init function. And I'll just write the template here. Then I'll write all that. Then, as we discussed here, we need enq, dq, isEmpty, and friend, right? See, def, what is the I need to do enq? Enq means I need to insert into the queue, right? Enq method. To enq, I need to insert some element into the queue, right? That is the element to be inserted. And then dq. Dq means I need to remove the element, right? So it doesn't require any input parameter. Just it needs to delete, and whatever the delete from the queue and whatever the item is deleted from the queue, we need to return. That is the part we need to implement. And then check whether the queue is empty or not. If it is empty, return true. If it is not empty, return false. And then return friend. What is the element sitting at the front end of the queue? This is the our queue class looks like. So see what, if you look at the Python provides a data structure called list, right? Python list. We can leverage the Python list to use to implement our queue. See, it has a list, right? List basically. So I'll what in the initialization I'll take self dot items as a list, right? So is equal to I'll initialize with the empty list with the no elements, basically empty list. See, and then what I need to, if as part of the enq method, I need to insert an element into the my queue, right? So what I need to do, let's maintain this order. Insert at the end always. Initially 0, 0, 0 is the index, right? So if I want to insert 10, just insert 10 at the 0th position. Just if I want to, then after that, if I want to insert 20, insert at the first position. And if I want to insert 30, insert at the, basically I'm keep inserting at the rear end. So essentially I'm doing append only. So just to self dot items dot append of element. This is the enq operations. See, what is the dq operation, right? So dq operation is basically remove the zeroth, always remove the element from the zeroth index. This is my friend, right? After removing, this will become zeroth index. Remove this and remove this and so on. So self dot items dot pop, from pop also has the zeroth. If I don't put 0 here, it removes the last element. So I want the element, zeroth element to be removed. So I remove that particular element. And after dequeuing, I need to return to the caller, right? Just return self.items.pop of 0. Is empty. If the list is empty, or basically if my queue is empty, return true. If the queue is not empty, return false. If self.items equal to empty list, just return true, else return false. Okay. So now what is the friend? Friend means remove the first element. Basically return the first element in the queue. Just I'll do return tq and return self.items of 0. This is our basic queue implementation. Let's test with some input data. If name equal to I'll call the main function def main. Here I'll create the queue object. I'll call it as my queue is equal to, I call it queue. Then I do my queue dot enq of 100, my queue of enq of 200. Similarly, I'll add 300 and 400. And then let's remove. If I do dq, I'll just remove and then print mq dot dequeue. Basically, it should print 100 now. If you see the output, it is printing 100. And then let's dequeue one more time. If I remove second time, it should print 200 because it should follow the first in first come order, right? First in first out order. In second printed, first dequeue prints 100, second dequeue prints 200. Let's try another 2 times. Basically, it should print 100, 200, 300, 400. Now, if I print one more time, see it gave some error because list is empty at this point in time because I remember queue is empty after removing 4 times. Now, there is some noise. Fine. See now, basically, I try at this point in time that our queue is empty, but we try to return the remove the zeroth element, wherein zeroth element it doesn't exist, right? So let's add a check here. If self dot is empty equal to false, then only if the queue is not empty, then only you return, right? Or else, see now I added this condition, like if the queue is not empty, then only you pop it, or else no point in popping, right? So we are not popping it, that is why it is printing none. Similarly, and here also we need to add this. If I want to here, so I'll add print mq.friend, it should return 100 now. Indentation. Okay. mq.friend, I'll add print here. If you look at it, it's print 100 here. Basically, a friend doesn't remove the element, just it returns. So if I add the same print at the end, after dequeuing 4 times, it will give again a trace back because the list is empty, but I'm trying to return 0th element. So here also, let's add this check. Now, if the list is empty, basically it returns none. So this is the basic queue implementation. So now it is a single-ended queue. We're inserting from one end and then deleting from another end. Basically, this also, if you look at it, this is insert from the end point, from end, then our rear end. Then this one is delete from front end. If I had 2 more elements, like insert from front end and then delete from rear end, it will become double-ended queue. So let's try that also. So def enqueue, def dequeue, this is rear end, then I'll call it as self, and here enqueue front, and then element to be inserted. This is the thing, right? So no build errors. So now what I need to do, I need to insert insert front means I keep inserting at this particular thing, delete from at the end, right? Basically, since we are leveraging the Python list data structure, we can do self.items.insert, which point I need to insert, 0th point and 0th index I need to insert the element. That's all. So now I need to delete from the rear end, right? So if I do, let's add this check as well, is empty equal to false, and then return self.items.pop. See, if I do only pop without giving any index, it removes the last element. So this is our enqueue front and delete rear methods. So let's test this thing with the same driver functions. Like instead of doing enqueue, I'll just do enqueue front and then enq friend, and then similarly enq friend. So here I'll do delete 3r, delete 3r, and then 3r. So delete 3r. So this is anyway, comment this. So even if you look at it, I inserted 100, 200, 300, 400, and even if you delete, the order should be in the same order which we had inserted, like 100, 200, 300, and 400. Now let's also insert maybe 1000, 2000. I'll insert 1000, 2000, and then let's delete twice. So again, it should print 1000 and 2000. Look at it, 1000 and 2000. It printed at time. See, this is a basic queue implementation. Basically, we can call it as a DQ also now, because it's we are inserting. We wrote methods to insert from the beginning and then delete from the beginning, and insert from the end and delete from the end. So, is it clear? The basic implementation of queue. Anybody has any questions? Fine, then I assume it's clear. If it's not clear, please let me know. I can explain again. So now let's jump into some problems. So that, see, this is the queue data structure. So just we implemented queue, but using the queue data structure, we can solve a lot of problems. See, basically the one, again, as I told, the application, real-time applications of QR is queues are like, even if the job's priority is same, then even our scheduler uses the queue concept to schedule the jobs. And then, and then even if you look at some of the tree traversals or graph traversals, right? If you want to do some breadth first search kind of things, if you want to search breadth wise, the queue is used as a auxiliary data structures. And in many to solve any for a lot of problems, queue has been used. Queue is being used as an auxiliary data structures to store the data uh, as a supporting data structures. So let's jump into a problem. This problem I picked it from lead code. This is the problem. See, given an array, given an array of numbers, there is a sliding window of k, which is moving from the very left of the array to the very right. Then let's this one. I think it's not okay. Yeah. The very left of the array to the very right, you can only see the k numbers in the window. Each time the sliding window moves right by only one position. Return the max sliding window. So if you look at, this is the input, right? If you look at the k is 3, that means the slide size is 3. This is the first slide. If I put this slide, what is the maximum number appearing in this particular slide? 3, right? So for this slide, 3 is the output. Again, move that slide by one rotation right hand side. So now this will become the slide. So what is the bigger element in this particular thing? Again 3, right? So this is the 3 is the output. Similarly, if you look at, this is the slide. It's clearly demonstrated in the example. -1, -3, 5. 5 is the bigger element. So print 5. Again, -3, 5, 3. Again, 5 is the bigger element here. If you look at it, the 5, 3, 6, 6 is the bigger element. And if you look at 3, 6, and 7, 7 is the bigger element. And again, this assumption, I mean, you may assume k is always valid. 1 is less than or equal to k, and less than or equal to inputs RSI. Basically, we don't have to write, validation around the sliding window size. And then again, one more constraint here, follow, could you solve it in a linear time? So basically, you should solve it in O of n complexity. Fine. So first, let me explain the problem once again. See here. 1, 3, 2, then 5, 4, 8, and then maybe I'll take it as 7. So if this is my input, and then if the window size k is equal to 3, right? So first I need to start from this. This is my window size. Correct, right? First I'll put it at this particular thing. And then which is the bigger element here? Here the bigger element is 3. I'll take it this as the output list or array or whatever it is. And then what is the bigger element? 1, 3, among 1, 3 and 2. 3 is the bigger element. So I add 3 into the output list. So then move the slide by 1 unit. So that means my slide will be something like this. Correct, right? This. Then I need to check the bigger element among 3, 2, and 5. 5 is the bigger element. Add 5 to the output. Again, this will be the starting point of the next sliding window, and then this will be the slide size 2, 5, 4. Again, 5 is the bigger one. And again, this will be the starting point, and this will be the slide. And then if I, because each time I'm moving the slide by 1 unit to the right hand side, 5, 4, 8. Here the 8 is the bigger element, and again this will be the slide, and then again 4, 8, and 7. 8 is the bigger element. So if you look at this one, the output will be 3, 5, 5, 8, 8. Yeah, this is a different example, and this is a different example. 3, 5, 5, 8, 8 is the big output. So this is a problem description. Is it clear? Any questions? Fine. How do we solve the problem? Let's discuss about the solution for this problem. But how can we solve the problem? See, if I take the naive approach, what I need to do is this is 1, 3, 2, 5, 4, 8, 7. This is the given input array. What I'll do is I'll traverse from this position to this position. So I'll traverse from for 0 to n. And then for each this one, traverse 3 times or size of k. Again, 0 to n, basically for I is equal to 0 to n. And then what I need to do here again, from I to k size, I need to traverse from here to here again. And then here again, find out the bigger element among this one. See again how efficiently we write the method to figure out the bigger element. That's also. So for, again here, traversing I to k, get the bigger element. The bigger element. See each traversal for each element traversing k. So the complex into k. But here again, I have not considered. I am assuming I'll figure out the bigger element in O of k size here. But again, it depends on how efficiently we implement that get bigger function. So if I look at the naive approach, the complexity would be input size into the window size, n into k. But if you look at the problem here, they've asked, could you solve it in linear time? So what is that? What does that mean? That means I need to iterate only once, so that I'll cover all the elements of n and then solve the problem. So let's see how we can solve this. I am not going to implement the brute force method because it's straightforward. And I mean, basically we need to traverse the entire array once, and then for each element traverse the k size, and then in this loop you figure out the bigger element. And once we find out the bigger element, just put the bigger element in the output list. So that is the naive approach, naive or brute force approach. But here our intention is to solve the problem with O of n complexity. Okay, let's see how we can solve the problem in O of n complexity. So I will clear this. Okay, let's see. 3, 2, 4, then 1, 6, and then 5. And then I'll take k is equal to 3. Window size is 3. See, I'll take a queue we can call it as, okay, single queue or a double-ended queue. Okay, let's see. I take a queue here of the size k, and then I need to traverse from year to year, right? See, only one time I need to traverse. See, just check whether my queue is empty or not, because whether I have inserted any elements into the queue or not. I have not inserted any element into the queue, so let's insert this part, zeroth element. Zeroth element is 0, 1, 2, 3, 4, and 5. Okay. I insert zeroth element, which is 3, into my queue. So now check whether the next element, first I need to iterate first 3 elements, because the size of, I'm taking the size of queue is 3 because that is the window size. First fill the my queue first, and then traverse the remaining elements, and then we'll see whether we can solve the problem or not. See, I inserted 0th element, which is 3, into the my queue, and then after that, just second element, right? This is not bigger than 2, so I inserted second element also into the queue. That means it is a 1 and then 2. 1 is the index and 3 is the value. 2 is the value. Then this particular 4 is the bigger element. So if you look at it, 4 is the bigger element, right? So that means if you take the first window, 4 will be the bigger element. Second window, 4 will be the bigger element. Third window also, third window we don't know. And the first and second, at least compared to 3 and 2 will never become the bigger elements, because 4 is the bigger. Even in the 0th interval and first interval, since 4 is the bigger element, it will not give a chance for 3 and 2. So there is no point in keeping 3 and 2 into the queue. So since 4 is the bigger element, remove this and then check this particular element. This is also 3, which is not bigger than 4. So remove this and then insert 4 into the queue. So the 2 is the index and 4 is the value which is present in the queue. Correct, right? So I filled my queue, and then let's try iterating the remaining elements of the given input. So since I'm traversing from this element, for the previous element, which is the bigger element, the one which is sitting in the queue, 4 is the bigger element. So I'll iterate maybe for k is equal to, or j is equal to 0, 1, 2, 3. That means k, third index, to n. The moment I iterate, I need to get the bigger element for the previous window. This is the previous window, right? What is the bigger element? The element which is there in the 0th location of queue. That means that is the 4. I add 4 in the output array. This is the output array. So now I get the front element from the queue, front of queue, and then add to result. Add front element to result. And now just check the validity of 4 is exist or not. Say for example, just I'll tweak the input here. I'll just take, okay, yeah, the 4 is still valid for 4 is valid for this input, for this window also, and then for the last window, validity of 4 will go, right? So let's check whether the 0, 1, 2 and the current index is 3 minus what is the bigger elements index, is 2. 3 minus 2 is equal to 1. That means if it returns 0, then assume this is the bigger element. If that is the case, 0, 1, 2, 3, 3 is the current index. If I do 3 minus 3 is equal to 0, assume 3 was a bigger element, then the validity will have 1. So since 4 is the bigger element, then please mute getting lot of noise. Okay. See this here. See, this is the 4's validity is not yet gone here, because if you look at the 4 minus the index of 4 is 2, that is, it is not yet reached 0. So 4 is still valid here. So then which is the current element? Current element is 1. So if it is current element is 1, just add that particular thing 0, 1, 2, 3. 3 is the index and value is 1 to the rear end of the queue. This is my rear end and this is my front end. Then yeah, that's all. Then it goes to the next element here. Then this k or j sits at the 6th value. And now again, if you look at 4, 1, 6, yeah, I need to figure out the bigger element for the previous window. Previous window is a 2, 4, 1, right? Again, 2, 4, 1, the bigger element is 4 again. So I'll add 4 into the queue, add front result to the result array. So now check the validity of 4 has gone or not. 0, 1, 2, 3, 4. 4 is the current index. Fourth index is 2. 4 minus 2 is equal to 2. That means the validity has not gone. Even if you consider 4, 1, 6 window, 4's validity is not yet expired, because in this particular window, 4 exists, right? 2 is validity of 2 and 3 are gone. So now I need to check the current element, but the current element is bigger than this 4 element, right? So now which is the current element? Current element is 6. And what is the index? 0, 1, 2, 3, 4. 4 is the index. 4 is the index and 6 is the value. So check my existing queue. So, but if you look at the rear end, the value is 1. Obviously 1 is not greater than 6. Let's remove this. Again check the fourth value. The value of 4 is again less than 6. Remove this. And then add 6 into the queue. I added 4 and 6 into the queue. So now you go to the next window, and then next, that means that this particular window 1, 6, 5. I mean 5. But while iterating this window, we need to get the value for the previous window result, right? 4, 1, 6. Again 4, 1, 6. You just pick the front end of the queue and then return the value. Front end of the queue is 6, right? So 6, add 6 into the result array, which is the result array here. And then now check validity of 6 in the, if you look at the window size 4, 1, 6, 6 is the bigger value, and we added 6 into the result array. Check whether the 6 is still exists in the current window. If you look at the 1, 6, 5 exist or not. Yes, definitely it exists. How do we calculate that? Check the current index, which is 0, 1, 2, 3, 4, 5. Current index is 5. And then what is the index of the bigger element, which is 4. Again 5 minus 4 is 1. So if it becomes 0, then it doesn't fit in the current window. It was in the previous window or as previous to previous window. So since it is not the after subtracting the current index and the bigger elements index in the queue, since it is not 0, it fits in the current window. So that means we need to still keep that particular element here. So then add 6 into the queue. So again, then yeah, that's all. We already iterated all the elements. Currently we're 5, and once it reaches the end, then you just return the result array, which is 4, 4, 6, 6. So let's trace it with one more example, just to check the possible where and all we need to add some conditions. So I'll take another example. I'll take 4, 3, 2, and then 1, and then 5. If you look at it, first interval 4 will be the bigger value. Second interval, this one 3 will be the bigger value. Third window, again 5 will be the bigger value. So let's see whether I'll create a queue of size 3, because my window size is 3. See, if the queue is empty, then write the bigger one, because I'll write both value and index. See, currently at the very beginning queue is empty, so I'll add the current index and then the value 0 and 4 added here. This is my current index. So again, go to the next index, and then check whether this is bigger than the element exist in the queue. No, this is not bigger, so no need to remove the element which is present in the queue. So add the current element and index into the queue. So 1 and 3. And then go here again, 2 is not the bigger element compared to 3 rear end of the queue. So let's add, 3 is the index and 2 value to the queue. So now iterate the rest of the array from year to year and then figure out the bigger elements. So at this point in time 1, I need to first get the bigger element for the previous window 432. Get the front element from the queue and then print it. What is the front element from the queue? 4. Just add it to the result array. I added that. Check whether the 4 is the previous window answer, right? Now I need to check for the current window. But in the current window, whether the 4 will fit into the current window or not. So if you look at it 3 to 1, it definitely it will not fit into the current window, right? So I need to remove 4 from the queue. So how do I check that? So this is 0, 1, 2, 3. What is the current window? J is equal to 0, 1, 2, 3. And then what is the index of the top element or front element? 0. 3 minus 0. I do 3 minus 0 is equal to 0. Yes, if it is 0 or less than 0, the validity is crossed. So let's remove this. Okay, and then I remove that. First thing, remove if validity is expired. This is expired because it doesn't fit into the current window. And then check whether what I should do with the current element j. J is 1. Check whether the j, if the j is bigger than these two elements, I need to remove them also and then add. Since here in our case, j is not bigger element, just add into the rear end. This is the 4 is the index and 1 is the value. Added it, right? So again, go back to the next iteration. That means this particular iteration. And then here, pick the bigger element in the previous window, 3, 2, 1. How do I pick? Just pick the front element from the queue and then add it. This is the front end now, right? So 3 is the answer, just add it into the queue. Okay, and then in the current window, 215, whether the 3 exists or not, it should not exist, right? Because it was exist in the previous window. So essentially I need to remove that from this particular thing. So how do I check using the same formula, like get the current index, which is 5, get the top index from the queue, which is 0, 1, 1, 5 minus 1, sorry, 0, 1, 2, 3, 4, 4 minus 1, 0, 1, 2, 3, sorry, this is not 0, this is the window size. If 5, 0, 1, 2, 3, 4, 4 minus 1 is equal to k. K is the window size 3. 4 minus 3 equal to 3, right? That means it is already, it doesn't fit into the current window. So remove this from the queue. Then for the current window, I need to check this guy is bigger than the rest of the elements in the queue or not. Check. Oh, okay. For looking at the 5, definitely it is bigger. So in the next particular window, 5 is going to, play a role instead of 1. So remove this also. Then check whether the 5 is bigger than 2. Yes, definitely it is bigger. Then remove this, and then after that definitely queue is empty. So add q into the 5 into the queue. That means 4 is the index and then 5 is the value added in the queue. So now at this point in time, it goes out of the index because I covered all the elements in an array. And then once I come out of the for loop, just return the top element from the queue, which is 5. Add this 4, 3, and 5. This is the logic we have to use using doubly ended queue. Basically, if you look at it, I inserted from the insert rear I did. Always I did insert rear. And also to check whether my current element is bigger than the rear element of the queue. If that is the case, I need to keep deleting the element from here to here, right? So again, what I did delete from rear end, correct, right? So again, if the validity expires of the given value, because top element or front element is considered as the bigger element, right? So if the validity expires, I need to remove the 0th element. I cannot remove from rear, right? I need to remove from front. I did remove from delete front. Delete front. These are all the operations I did. If you look at it, delete, insert rear, delete rear, and then delete front. So, but again, it is a queue. So I need a queue with these three operations to implement this solve this particular problem. So just before a couple of minutes, we had discussed about doubly ended queue, right? So we can leverage the doubly ended queue to solve this particular problem. So is it clear, the algorithm? Or you want me to explain once again with by taking some other problem? Anybody? I think you are on mute. You can unmute yourself and then. Hello? Is it clear, guys? Can anybody confirm in the chat window or? Fine. Okay. Fine. Let's implement it. Instead of. Okay. Thank you. So now instead of these are all the things. So Python, we can leverage the just implemented data structure. We implemented this double-ended queue, right? This also we can uh, take it, or if we want to use the built-in queue data structure, that is also we can leverage. We can use. If you look at it, the Python from collections, there is a module called DQ. If you look at this is the collection Python documentation. Python has a DQ, okay, from collections module. See, this is the basically append does the insert from the right side of the queue. Append left inserts the left end of the queue, and then pop left removes from the front end, and then pop removes from the rear end. So here in this example, we wanted insert rear, right? This is basically append left. If you leverage the Python built-in module, delete rear is pop, delete from front is pop left. Okay, so let's leverage the data structure and try to solve the problem. I'll directly this is the I just click, this is the problem, right? This is the lead code link, and then if you find, yeah, we can say so. Okay, this is a problem. If you look at this, the same problem I have taken up, and this is that we can try to solve the problem. So what I need to do, I need to have a queue, right? So let's do import collections. Okay. And then what I need to do is I need to create my queue with the size, the k. And again, if you look at the documentation, if you want to create the queue with certain size, you can leverage this max length keyword. So what I'm going to do here is I'm going to create a DQ. My DQ is equal to collections dot DQ. Created a DQ. Which end removed from pop left? Okay, if the queue is 1, 2, 3, if I do pop left, it removes 1. Basically, element which is sitting at the 0th index. You can think in that way. And if you do just pop, it removes the 3x. Okay, is it clear? Basically, pop left means it removes 1x. After removing that, if I do again pop left, it removes from 2x. And again, after that, if you remove 3x. And if you assume if we have elements like 1x, 2x, and 3x in the queue, and if I do just pop, it removes from the right end, which is 3x. And again, if I do append, it inserts after 3x. And if I do append left, it inserts before 1x. And if I, okay, this is the NQ we did, right? This is something like, I'll call it as, see, this is like append, and this is like append left. This is DQ from front end, right? So this is basically the pop left. And DQ rear, this is basically pop. If I compare our implementation versus the collection DQ method, only the names are different. It is up, instead of calling NQ front, they called it as append left. Instead of calling NQ, it is append. And instead of DQ from zero, I mean, we just called it DQ. It's a pop left. And then DQ from rear end, it is called as pop. Hope it's clear now. So let's jump into the implementation. I created the collections DQ, right? So now what I need to do here, I need to, I'll just rewrite. I'll just take the sample example and then I'll convert that to code, right? I'll call it as 4, 3, and then 4, 3, 2, 1, and 6. See, in the first queue, I need to check if the queue is empty. I need to insert the index or value 0, 1, 2, 3. In the example, I was just showing as the index and value. If I have the index, if I dereference that index, I'll definitely get the value. By pushing the index is also sufficient. We don't have to push always the index and value. So if the queue is empty, first I need to parse the element from 0 to the window size of the element. That means 3 is the window size, right? So traverse for I to 3 and then fill my DQ. So here for I in range length of k, not length, sorry, I in range in k 3 times, right? Just I'll print it. After that I'll just run this code. DQ, what is this? DEQUE, sorry, DEQUE. Okay, I just printed 0, 1, and 2. These are all the elements, right? Now I need to add into the queue. So what are all the methods it has? I'll just do append left, then pop left. Append left, anyway, we're not using it. Pop left and then pop. These are all the methods I'm going to use, and then I need to check whether the queue is empty or not. Initially, if not DQ, that means it should be empty, right? Just I do print empty, else print not empty. I'll just run this. Okay, this is printed empty, and then I'll do just for the demonstration, I'm adding a couple of entries. Just DQ dot append of 0. If I add, it should print not empty. Okay. Oh, it is not empty. That means I can use this check not DQ for the empty. Empty check is empty equal to something like this. Fine. I'll remove this, not required now. For I in range, I traverse the size of the window. If not DQ, what should I do? If the queue is empty, I have to just insert that particular index into the queue, right? DQ dot append of what I. And go back to this one. I added 4 in 0th index, basically 0th index and 4th value into the queue. And then next check the second element. Then for I is equal to from year to year we're iterating, right? Next element, whether check this particular element is bigger than this. If it is a bigger than this, I need to remove this. If it is not bigger than, just I need to insert again the same thing, right? That means if the queue is empty, or if the queue is empty, or current element nums of I is less than the last element rear end of the queue. How do I get the rear end here, right? One more thing, how do I get the rear end? I can just do dq of -1, because Python provides the negative index also, right? Or else you can do a dq of length of the queue -1, or else you can do dq of -1. If it is rear end is currently 4, if this particular element is the 3 is less than the rear end element which is sitting in the rear end, so since it is less than, just I need to insert that element into the queue, or dq of rear end. If I do dq of -1, it fetches the index, but I need to compare the value with the array value, right? Just I'm doing nums of dq of -1. Just I append it. Fine, I added it. Okay. This is what I should do in the else condition, correct, right? So now if this is the condition, I need to add into the queue. What if the condition is something like, assume now also added, what is that, 1 and 3 here, and I go at this particular unit, third element, assume it as 6. If it is 6, current element also for this window 6 will be the bigger value, next window also 6 will be the bigger value, provided this particular element is less than the bigger value. So if it is a bigger, I need to pop all the elements, right? This also I need to pop, this also I need to pop. So in this particular thing, queue is not empty and the current element is bigger than the rear end of this one. So what I should do, I should remove this, and at the end add the current element. So else, in a loop I need to remove, right? While current element, that means nums of I is greater than nums of dq of -1 last element, what I need to do, I need to pop that particular element. Just do dq of pop. Okay, fine. I popped this particular element. I popped 1 and 3 because this guy 6 is bigger than 3. Again check the next element present in the rear end, which is 4. 6 is again bigger than this one. So I popped both the elements. Now at this point in time, queue becomes empty, right? So if queue becomes empty, what we have written here? If queue becomes empty and I can't check, because dq of -1 will give the a trace back, because -1 queue is empty. I'm trying to fetch the last element in the queue. So that means if the queue is empty, just come out of the while loop. If not, well, how do I check whether the empty not dq, right? If not dq, just do break. That means it comes out of the while loop. And then once I come out of the while loop, that means I can ready to insert my current element into the queue, right? See, there are two things. If the queue is empty, then also it becomes it comes out of the while loop. Or else assume this has a assume this is something like 6, 3 and then 5, and then I've inserted 6 into the 0 and 6 into the queue, and then 1 and 3 into the queue. Currently what is the element I'm processing? 5. So 5 is bigger than 3. I pop this element. Then what is 5? 5 is not bigger than 6. So that means it comes out of the while loop. Now I need to insert the current element. So now you do dq of append of the current index I. So I did processing for the, I just processed my current queue. I just initially I filled the elements with the queue. My queue size is 3. That means K, and then I inserted elements into the queue. Okay, is it clear till this point? Fine. So now let's run and then check whether there are any errors or not. Okay, output is null. We are not storing, and we are not writing anything to the console, so it is the expected. Okay, then this is first part is done. Now we need to process the remaining elements of an array, right? See, what are the remaining elements? If you take, okay, let's take this example only. 1 3 minus 1 minus 3, 1 and 3, 3 minus 1 minus 3 5, 3 5, 3 6 7, 3 6 7. And what is the window size? Window size is 3. 3, then k is equal to 3. So now I created a queue of 3. Initially I inserted 0 and 3, this guy, and then 3 is bigger than 1. I popped that particular element and then added 1 3 into the queue, and then minus 1. That means 2 is the index, minus 1 is the value. This is my queue, current queue, and this is I filled. Now I need to iterate the rest of the elements. This is my I, that means 0 1 2 3 4 5 6 7. This is the index. So check the current element needs to be processed. Just I need to iterate rest of the elements, right? Right. Let's write the skeleton here. Okay. For j in from range, I need to start from third index, right? What is the index I need to start? 0 1 2 3. What is 3? 3 here is k, right? I need to start from k till length of the elements, length of nums. So now let's print it. Should print from 3 to just I'll printing it 3 4 5 6 7. It should print. Just I'll print that. Print j. Then see, if you look at 3 4 5 6 7, these are all the elements I need to process now. So just before processing the first element, third element, this is the third element, I need to get the value for the previous window, right? What was the maximum element in the previous window among 1 3 and minus 1? That means whichever is present in the front end of the queue. So I'll take the result array as a, because if you look at it, result array is a list of integers here, right? So I'll take result is equal to empty array. I'll just do result dot append of what I need to do. I need to do pop the front element. Front element means pop left. dq dot pop left. If I do dq of pop left, I'll get the index. I need to get the value out of it, right? So nums of is the value. Okay, let's run it. Pop an empty dq. Line number 25. Print dq. Just I'm checking what's happening here. dq1 and 2 exist, that is this and this, but why? Okay, print dq of pop left. If I print that, okay, it should print test. Okay, it's basically returning here. Okay, fine. I'll do one thing. Now here we need to do index is equal to dq of pop left. Now I do result dot append of nums of index. Now I'll print my result here just to see what is the value. Pop from an empty queue. It is pop left. Fine, we can pop. I'll pop from this thing only. Then okay, why it is throwing. Okay. Oh, I should not pop. Just I need to get the element, right. I should not pop it. Just I should get the 0th element and print. So while calculating it, I need to process. So get the pop front element. That's all. How do I get the front element? Yeah, right. I need to just get the front element from the queue and print it from the queue and print. Right. So how do I get it? The 0th element. DQ of 0 would be sufficient. So just I'll not pop it. Just I'll do DQ of 0. Append it here. So yeah, because I need to do only one time, since in a loop it is printing 111. Result of DQ of 0. The DQ of 0 will give the index, but I need to have the value. So I did this. Correct, right? 3. Okay, let's go back to the example here. See now I am processing this particular element, which is the bigger element is this guy. Just I need to append that value in the result, that is 3. Get the index, from that you dereference, will get the value 3 and add into the append list. So now I need to check whether what should I do with the current value, right? So if the current value is bigger than this guy, or queue is empty, I need to if the queue is empty, I need to insert this. Or else, if this particular element is bigger than the rear end, pop and delete it. And also I need to check the validity of this one, right? First, I need to check the validity. How do I check the validity? If j minus dq of 0 is equal to k, validity is expired. Let's add the check first here. If j minus dq of 0 is equal to k, validity is expired, I need to remove, right? So now do pop left, run this. Because I just do break here, because it's first it pops and then it goes in a loop, right? That time it is failing. Just its logic is not yet completed. Okay, now I did the pop left. That if the condition is validity is expired, I popped it. Now what I need to do, if queue is empty, not dq, again validity is expired, I removed it, right? So now I need to insert -3. If the queue is empty, I need to add it. If the current element is less than this particular element, I need to add it. That is the first adding conditions. If not dq, if queue is empty, or nums of j is less than nums of rear end. Then also I need to add it dq dot append of j. I added it. Else it's pretty much similar to this particular conditions, adding condition. Now else what I need to do, I need to check if this guy is bigger than this, remove from the rear end. I'll just else while nums of j is greater than nums of dq of rear end minus 1, what I need to do, just keep popping element from the rear end, pop. And then again, if q is empty, just come out of the this one only. Okay, dq is empty, just break. Else either q is empty, you come out of this one, or else you add it dq dot append of j. Okay, and then once your loop is done, for the last element, whenever you are at this, when you go out of the in the elements, right, when you processed all the elements, you need to pick the element from the dq and then print it for the last window. Just add result dot append of nums of dq of 0. I'm printing the result here. Let's see what does it print. See, if it is showing output as null because we are not returning anything. But if you look at the what we are printing, test is just the string. You can ignore this. I'll delete. Then 335567 335567. This is the result. So now comment this line. Just return the result. So now if I run this code, see it shows in the green line. That means this particular test case is passed. Now let's submit the code. Okay, it is showing it is failing for something. See, it is saying index error, DQ index out of range. What are the details? Let's check. Okay, basically for the empty input, it is failing. Let's go to the test case and then let's empty. And what is the window size? 0. So if I add, again it is failing. So because it is not entering into any loop, but we are trying to do this. What is the expected? Okay, if length of nums, they passed empty, right? Length of nums equal to 0, just return empty list. They should solve the problem. Sorry. Just run the code. Yeah, output is empty, expected output is empty. It is in the green line. Now let's submit. Okay, if you look at it, it is saying accepted. It took 112 milliseconds and this much is the memory, and let's click on the accepted. And these are all the efficiency graph of our code. And if you look at it, it executed again 18 test cases, and pretty much all 18 test cases are passed. And if you look at the problem complexity, I think it fits into some the category is hard, I guess. Reading window maximum, right? Let's go back to the problem. If you look at this category, it is a bit complex, they say, but if you understand the queue data structure thoroughly, it's not that complex at all. It's easy to solve. So yeah, this is any questions so far? Is it clear? Or you want me to explain once again? I think you are on mute. You can unmute and talk, or else you can put in the chat window if it is clear or not clear. If it is not clear, I'll explain again if it is clear. Okay, fine. Okay, okay, fine then. Anybody others has any question about Q, DQ? It could be a question you can ask. Where, okay, just I take this problem. This is what's right. Then this is what our solution to the problem. Just I paste it here. Okay, fine. Fine then. Let's move to the next problem. Next problem is this is the problem statement. Just take out 2-3 minutes and please read the problem. Then after that, I'll explain the problem with an example. Okay. Yeah, the problem is something like this guy announced that the school will host some competition where four schools are going to compete against each other. Four schools are going to compete against each other in a very deadly competition by facing some dangerous challenges. Since the team selection is very critical in this deadly competition, this particular guy asked some monk to help him in the team selection process. There is a long queue of the students from all the four magical schools. There are basically four schools, right? From each school, lot of students comes to join the competition. Each student of the school have a different roll number. Each that is obvious, right? Each student of the school have different roll number. Whenever a new student will come, he will search for his schoolmate from the end of the queue. As soon as he will find the schoolmate in the queue, he will just stand behind him. Otherwise, he will stand at the end of the queue. At any moment, that this particular monk will ask the student who is standing in the front of the queue to come out, and then he'll put his name in the selection process. So basically, there are four schools, right? I will just explain the problem here. Four schools. I'll call it as maybe school 1, school 2, school 3, school 4. These are the school IDs, you can call it. And this is the main queue. And what that monk does it, this is the big queue, whoever standing in the queue at the very beginning, he'll just take out his name and then he'll put it in the competition thing. That means that guy is selected. So that is how he selects. He doesn't care who is standing in the front. Whoever is standing in the front of the queue, he just take him and then he select him for the process. So now, what is the enqueuing process? What is the what student will follow it? Say for example, this is the main queue, and from this first school there is a roll number 10, 20, 30. Maybe you can call it here 40, 50, 60. Three people are there, just for the sake of example. 70, 80, 90, 100, 110, 120. Assume first 10 roll number from first student comes and then stand in the queue, 1 comma 10, right? Then this guy comes 2 and then 50, you can call it this 2 and then 50. How he stands here? Because he checks whether somebody is there standing in the school who belongs to my school or not, because only one guy is standing in the queue. That guy doesn't belong to our school, so it just he stood at the end of the queue. Now what, again 30 from first school comes. He scans from the first guy. Oh, this guy is from our school only. He'll not go back to the end. Just what he'll do, he'll come and stand here, just behind him. That means 1 and 30. Then this guy will be 2 and 50 here, right? So again, maybe 3 and from 370 ID from 20 roll number guy comes from the third school and checks whether anybody from our school standing in the queue or not. No, this guy is from first school. This guy is from first school. This guy from second. Nobody is standing. So he's the first person who goes and stands in the end of the queue. 3 and 70. So now again assume 20 guy comes here, just he checks here, 110, oh, this guy is there, but he can't stand here. He has to go at the end of this particular 1 comma 30, he comes at this particular thing. So 110, 130 and then 120. And then obviously remaining students 250, 370. So now again 40 from 2 comes. He checks from here, no, this guy, yeah, he's from our school. Then just I go and stands at this guy. And again maybe 60 from 2, again he comes and then stands after this guy. So if again 80 comes, maybe he stands behind 370, 380, right? Again, if somebody comes from fourth school, nobody is there here, so he goes at the end and then stands here. So what that guy does, he just always, if I do DQ, he just picks this guy and then adds into the fire or whatever. This is he puts into the selection process. This is what is the problem statement. Is it clear? Problem? Okay. Fine. How do we solve this, right? So again, I'm not going to discuss the naive approach. Naive approach, just we'll see how we can solve effectively using with the best time complexity. See, this is the main queue. See, if you think, that means I have a school IDs 1, 2, 3, 4. Correct, right? This is the main queue. And what is the input I get? If you look at if you observe the input carefully, this is the NQ. That means he has to go and stand in the queue. DQ means who does the DQ? This particular monk does the DQ, and then whoever comes out, he puts into the result array. This is the output we expected. If I take this example 1, 1, I added 1, 1 in the queue, in the main queue. 1, 1 in the main queue. Second 2, 0 comes. 2 is the school ID, and the second one is the roll number you can think of. Then 2, 0, nobody is there from our school, just in this guy. Then 1, 2, 1, 2 he comes, and then he basically has to stand behind the roll number 1 guy. And then 3 students, right? Now what I do, DQ. If I do DQ, I should DQ this first and then put in the result array 1, 1. And again, if I do second time DQ 1, 2, this should be the result array 1, 1 and 1, 2. So if you look at the output is 1, 1 and 1, 2. So this is the problem. So how do we solve this problem? Say let's take, this is the school 1, this is the school 2, this is the school 3, and this is the school 4. Anybody, any idea how can we solve the problem? Fine. See, what I'm thinking is, in order to solve, this is the one main queue. This main queue is basically used by that particular mountain. It doesn't care how people, I mean, only one process is there, and then they go and stand it. Whenever you want to pick any guy, you just pick the 0th element, and then you put in the result array. That's the selection process you can think of. See, what I'm thinking is, see, this is the for each school we can maintain a one queue. This is my queue of the school 1, and this is the school queue of the school 2. This is queue of the school 3, and this is queue of the school 4. And first guy comes 1, 1. Check my corresponding school queue. This corresponding school queue is empty. Okay, if the current corresponding school queue is empty, put me in the current school. That means 1 is the roll number, and put the school in the main queue. Okay, 1. Okay, then assume 1 2 1 1 1 2, and then 2 10, then 3 10. This is just input I'm taking. Then 115, and then 215, 225. I'll call it. Then 1, then this one I'll put again 1 and 2, right? Again 1 2 comes here. Check the my school queue. Oh, somebody is already there. Don't even check the main queue. Go and stand it here. Roll number 2. Then 2 to check whether my queue, somebody is standing in my school queue. Oh no, this but nobody is standing. So just I'll go and stand. This is my roll number 10. And then this I'll add my school ID in the bank here. So then 310. Oh, somebody is already there. Just I'll go. This is 210. Sorry, 3, right? 310. 3 is empty. My school queue is empty. Just I'll go and stand here. Then add in the main queue 3. It's also done. 115. Then I go to the one. Oh, my school queue is already there. I'll stand at the end of the school queue, and I'll not add because the school ID is already added in the main queue. This is also done. 2 and 25. Go and stand in the 25. Then I'll call it as 450, and then 440. You say, okay, I'll check queue is empty, so add it here 4, and then I add 50. Then 40. Oh, somebody is already in there in the my queue, so go and stand in the queue. So now the criteria is if I remove this guy, I don't care, right? I need to pick the first element from the main queue and then result. NQ is done. Now I need to do the DQ. Assume if I do DQ, 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 oh, what order I should get? I should get 1, 1, 1, 2, and then 115 I should get it, right? So all of them are in there in the my first queue only. Okay, let's see. If I do DQ, DQ operation, I'll go, I'll get this guy, okay, and then pop this guy from the front, and then get the corresponding school ID. School ID is here only, right? 1 and 1, and then check whether this queue is empty or not. Oh, this queue is not empty. That means still people are there. So don't do anything. This DQ 1 1 is there, and then again I do DQ operation. Just go to the first queue and then get DQ. Just do pop of this guy, and then get the school ID 1 and 2. And then do again. If I do next DQ, go check, remove this guy 1 and 15. By the time I remove this guy, this queue becomes empty, right? If the queue become empty, just remove this guy from pop. You do pop from this guy. I remove this. So it printed, adding the result array. Let's say assume I do DQ. DQ, what I need to do? If I do DQ, go to this main school ID, okay, 2. Oh, go to this particular school ID, remove this guy. If the queue is empty, I need to remove this, but queue is not empty. So if I do DQ, what is the answer I get? 2 and 10. And then if I do one more DQ, again, go to the main queue, get the school ID, go to the school queue, and then remove this guy to 225. Now this queue becomes empty, so pop this guy. So if you look at the order, it is coming in the same way: 1 1 1 2 1 15 2 10 2 20. And then for the next one, if I do DQ again, go to the main queue, get the school ID, go to the school queue, pop this guy, print 3 and 10, and then just to the moment we did pop, this queue becomes empty, go and pop this guy. Similarly, go to if I do DQ, get the main queue, only 4 is there, then go to the corresponding school queue, pop and print 450, and then 440, and then pop this. You keep repeating the process, you will get the answer. Basically, it is efficient. Moreover, only the thing is we use couple of queues. That is the thing here. So, any questions? Is it clear or not clear? If it is clear, we can go and implement this. If it is not clear, I can explain the theory again. Is it clear? What do you guys think about the problems? Do you think they are easy problems, medium, or hard problems, or you want me to take little bit less complex problems, or bit more complex problems? How is it? So that that input will help me to take next set of problems in future videos. Theory is clear. Can you? Okay. Okay. Fine. Then I'll go. We'll go ahead with the implementation. Please stop me if you don't get it or if you have any questions. Okay. See, if you look at it, what are all the operations I did? All the queue operations only I did, right? So I'll use the queue data structure. Okay, and then I will implement it here only. This is queue. I don't need delete here. I am not thinking to use doubly ended queue. Only the normal queue is sufficient. So enq deq is empty friend. These are all the methods I want. So I deleted unnecessary methods here. So let's do if name equal to main, call it main method. That's main method. Okay, now what I should do here? I should create one main queue. Correct, right? I'll call it as main underscore queue is equal to queue. Okay. Then after that, I need to what is the school? They're saying if you look at the problem description, they have total 4 schools, right? So I need to have 4 queues also, 4 school queues. I'll do. I need to create school queues. Basically, it is something like this, like Q1, Q2, Q3, 4, right? So 4 queues, list of queues I need to have. So school queues is equal to, I'll initialize with this. For I in range. Okay, let's forget about the 0th index. So okay, let's see. I'll create. Just I'm thinking to keep it simple. School queues dot append dot. I'll create an object. Print main queue. I'll just do print school queues. Just I'm printing. Let's see. Okay. This is the main queue. It's printing from address. Okay. And these are all the school queues I'm printed. See this one also. Okay. Yeah. I created school queues and I created main queue. This one you can. Okay, this is the simple way I implemented. You can replace with this one also. List compensation also, if you want to use, you can use it here. Something like school queues is equal to just I need to use something like this for I in range of 5 bit. Okay, yeah, this is also fine. If you look, if I remove this, essentially both are same. I mean, okay, let's keep the simple one only. It will be easy for understanding. Okay, now how do I get the, sorry, this I shouldn't have done in the main. Let's call it as this one only. This is the input, right? Input array is equal to this. Solve, I'll call it as challenge of input array, and then I'll call it cell. I'll cut this. Syntax error. Challenge. Sorry, what happened? Okay. Something, okay. Okay. Now I'll call some challenge of input array. We'll take this as input array. Okay, I'll call it as main q is equal to q1, this one, and then for individual school queues, right? School queues is equal to empty. School queues is equal to I'll just write for range of 5. Because if I take 4, I need to do subtract by 1 to get the previous index. Just I'll put it 5. Let's optimize it later. Then I initialize this. Print main q is equal to this. Then school q is equal to this. Dot format main q. Just I'm printing school queues. Look at this. This is the main queue. One object is there. This is the school queue. Those objects are there. So now what should I do? I should, this is the input, right? These are all the, I got the in, and then iterate that for I in length of input array. Then print I. Just I'm printing it. Okay. Checks are not iterable, not length, sorry. This is okay. This is the each element is I got it E11, E20, E12, D and D, right? So this is the operation, and this is the school ID, and this is the roll number. Correct, right? So I'll call it as school ID. Sorry, I'll call it as operation. Operation is equal to input array of 0. School ID, I'll call it as SID, is equal to input array of 1, and then I'll call it as roll number is equal to input array of 2. Okay, now let's, I assigned it. Okay, print OP, comma, CD, comma, roll number. It is oh, sorry, I should have done not input I of 0. What is the array string of 0, 1, 2, 0, 1, 2? It is string. Any idea why it is throwing? Okay, yeah, because it is showing for these things. If I, because it doesn't have 1 and 2, right? So let's okay, let's split it. If I of 0 equal to NQ, then only 1 and 2 comes into the picture, or else it doesn't come into the picture, right? So now, see, now it did not throw any error. So this is basically NQ operations we need to do, and the other one is DQ operation. If I of 0 equal to DQ, so I'm not doing anything at this point. Let's fill it later. Okay. So this is the, no, let's, what I did, okay, this is the main queue and this is the this thing. First guy who comes, I get the school ID and check the role school ID and check whether the school queue is exist or not. If school queue doesn't exist, just append that the roll number, append the roll number. If school queue doesn't exist, then create a school queue. I mean, basically created a school queue, add the roll number and also add it in the main queue. If okay, here we have empty also, right? If you already have the school queue, just we need to check whether it's empty or not. If school queues of school ID of is empty. If it is empty, what should I do? School is empty. Just add dot append or what? NQ, sorry, NQ of the roll number. If it is add the roll number, and or else just if it is not there, if it is not there, just I need to create the main queue entry also, right? Main queue dot NQ of my school ID. I'll create it. If it is empty, I need to create in the main queue also. And then this, whether it's empty or not empty. If it is queue is empty, then also I need to insert. If the queue is not empty, then also I need to insert. See, if I add it here, then also I need to add outer while loop also. If queue is not empty, then also I need to find the school ID and add it, right? So we can remove this particular line. Okay, that is what I did. I just checked whether my school queue is I exist or empty or not. If it is empty, I created my school ID in the main queue. I enqueued basically, and then added this one. Again, I go 1 and 2. This is already exist. That means it is not empty. Just go and insert it here. NQ operation is done. So now, how about the DQ? DQ, right? Assume I did, as I told, one is there. Assume here I'll rewrite it. 1, 2 is there. Sorry, 1, 1 is there. 1, 2 is there. Then if you look at 115 is there. And then here 10 is 210 is there. 225 is there. Here also 10 is there. Here 4, right? 50 and 40 are there. So when I want to DQ, just go and pick this guy. Just go if dq dq, right? Get the school id. School id is equal to main q dot friend. Okay, I get the main school and go to that particular school id. That means school id dot this, and then you do what I need to do. I need to do dq this. I did this dq. I'll get the roll number is equal to, this is the roll number to be dq'd. Whatever the roll number I dq'd, I got it here. Now you just do print dot format school id and roll number. So, and then after that, if school id dot is empty equal to true, then you delete the main queue. I mean dequeue the main first element from the main queue. What I need to do, main queue dot bq. Yeah, that's all. Let's run this. I'll comment this. This is the only thing, right? See, 1 1 and 1 2. This is the 1 1 and this is the 1 2. If I do dq again here, we should get 2 0 also. I get 2 0. Correct, right? So I've added a couple of print statements, I guess. That is why these things are meeting. Let's search. Okay, this is the I'll comment this. Okay, let's add this example 1 1 1 2 2 10. 1 1 1 2 2 10 3 10 1 15 3 2 10. After 2 10 3 10 1 15 3 10 1 15 15 2 10 3 10 1 1 1 2 2 10 3 10 1 15 225 1 15. Okay, this is sufficient. Okay, 1 2. Okay, if I 1 2 3 4 5, I do 5 times decrease. Yes, okay, okay. If you look at it, 1 1 is the first answer, 1 2 correct, then 1 15 correct, then 2 10 correct, then 3 10. So if I add one more 215, 200 I put, and then run, 200k. So if I add one more DQ here, 310 also it came. Yeah, this is what the implementation is. Any questions? Okay, that's all from the sessions. If you have any questions, please ask, or else we can wind up. Okay, guys, thanks for joining. Hope any questions? Is it clear? Fine. If there are no questions, we can wind up. Thanks for joining. Thanks a lot. Have a good day. Bye.